Hello! You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
2 West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
Yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady.
And Levi.
And Brady, too. We're the 3 members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed.
That was the one thing.
Which makes it a rap.
Yes. All raps have one rhyme.
We'll see you on 2 West.
Yes. 2 West.
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because
disgusting gray moths.
Yes, those gray moths that you hear, they're like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all.
Okay. Here we are. Everybody's here except for Levi, which means that it's just me. It's just me. I know you're thinking, this is awesome. I know. I'm thinking the same thing. And I'm cleaning my glasses right now because they've been kind of dirty. Got dirty glasses. Every time I try to clean them, they just... there's like no... I'm using the wrong fabric or something. I keep pushing around those little swirly, watery lines. Well, this has probably got to be the most engaging channel on Twitch right now, by a long shot. It's a guy in front of a black background cleaning his glasses and complaining about how it's difficult to clean his glasses. Oh my, this looks terrible. Is it? Am I God. And I'm gonna put them on. It's worse than where it started. It's absolutely worse. All right, you know what? Then this is just not gonna be on right now. That's what's gonna happen. Not Koozie, are you around? You post a lot of problems. That's excellent. I'd like to do them, if that's okay with you. Only if it's okay, though. All right, maybe my shirt will be better at this. Will it? A little bit. Say hi if you're watching. I see we got a couple of viewers. I'm ready to do it big time. We're going to have a good time tonight. We're gonna have a good time tonight. Hey, it's a celebration that lasts all the night. We're gonna celebrate good times. This is just making me frustrated. I clean them and then there's water on them. And so I like shake it off. There's still some drips, but man, it's clear. It's great. But I'm like, I gotta get rid of the drips. And then I try to get rid of the drips. I definitely shouldn't use a piece of toilet paper. That was probably the wrong call. I guess we'll go ahead and get started here with Nakuzi's first question. All right, let's see what we got here. I'm gonna make this thing huge. There we go. Not Coos. Are we streaming? We are. We're streaming. Okay. Huh. I'm gonna restart Restream. So I'm gonna guess people have been saying stuff and it's not coming up. There it is. All right, we're gonna restart here. Restream. Here we go. No, not that. This is a disaster. With Levi gone, everything is just falling apart. Come on, Restream. Where's Restream? There it is. Okay, let's see what we got here. Let's get this chat going. Okay. All right. Say something if you're watching, because I don't think I was getting previous messages. Don't be afraid. You can't hide. There we go. Not Koozie. I see you. We're good. We're good. I'm sorry about that. I don't know what is going on, but we're good now. Okay. All right, we got stuff to do. We have a lot of fun stuff to do. Where's Levi? He tried to catch a bus, and the bus was full, so we had to get the second bus. So he'll be here in probably like 45 minutes. But until then, it's just me. Just me. What everyone is always wanting anyway. Levi is just a distraction. I've always said that. The gas mileage for a car. SMH. Shaking my head. Yeah, I know. Gas mileage for a car is 23 miles per gallon, when the car travels 60 miles an hour. The car begins a trip with 13 gallons in its tank, travels an average speed of 60 miles per hour for 8 hours, and ends the trip with 10 gallons in its tank. Which of the following equations best models this situation? Oh, this is excellent. Okay, I suppose I probably should put up the answers here. But let's just talk about this for a sec. Your mileage is when you're traveling at 60 miles an hour. The fact that that was their average speed means that their average mileage was 23 miles per gallon, so we're allowed to use that. And they started with 13 gallons and ended with 10 gallons. So clearly they've used 3 gallons. That must have been what happened. If you start with 13 and you end with 10, this is first grade. You lose 3 gallons in order to get there. So if they are using 3 gallons and they get 23 miles per gallon, we think about this in terms of dimensional analysis. We have 23 miles per gallon, and we have used up 3 gallons. So gallons cancel out. We multiply 23 by 3. That gives us 69 miles. That's how long we just went. So now let's take a look at our equations. See what makes sense. Okay. Here we go. Okay, so things that I just did is I thought, what amount of gas have we lost? And, okay, interesting. Look at these. They're setting everything equal to 10. Okay, so everything is 10, and everything starts with 13 for the most part. We have 13 minus stuff, okay? So what they're doing here is they're saying we're starting with 13 gallons, we're subtracting some amount, and then we're ending up with 10 gallons. So that amount that we're subtracting has to be 3. 13 minus something equals 10. That something has to be 3. So C and D, they're subtracting 60H. 60 miles an hour times the number of hours. That would give you the number of miles. Okay. So 60H, let's talk about that for a sec. So 60 is miles per hour. And if they're multiplying that by H hours, hours are going to cancel out. You're going to get 60H, and the unit of that is miles. So that's what 60H represents. It's the amount of miles that you've actually driven. So let's go through these. Okay, so with A, we have 13, which is our starting gas. And 23h over 60, if we're subtracting that and getting 10, that should be 3. So will that make sense? Models the situation. 23 is the miles per gallon times the hours. That is a problem. Miles per gallon should not be multiplied by hours. Miles per gallon has nothing to do with time. And they're dividing that by the speed, which is 60. Yeah, no, you probably don't want to do that, but just to make sure, that would be miles per gallon. They're multiplying that by time, which is hours. So it's going to become hours over here. And they're dividing that whole thing by 60, which is miles per hour. Dividing by miles per hour is the same thing as multiplying by hours per mile. So this thing is just becoming a mess real quick. Miles cancel out, but this is going to get you hours squared over gallons, so that is just a disaster. You don't want that. All right, so with B, 60h over 23. So 60 times h would give you, like we said, miles divided by miles per gallon. That is far more promising. If you take miles and you divide it by miles per gallon, this is fraction division. So this is equal to miles over 1 times gallons over miles. Miles will cancel out, leaving you with gallons. So that will be an expression that gives you a number of gallons. So 13 minus a number of gallons is equal to 10. Unit-wise, that's exactly right. The rest of these are taking 13 and dividing them by something. That is not the right call. 13 is 13 no matter what you divide. You don't need to divide 13 by anything. It should just stay 13 because that is the starting value of gas. I hate these questions. The unit questions, not koozie, they can be kind of annoying. Yeah, I agree. Does this whole like crossing stuff out thing make sense? Because that's kind of the crux of it. Otherwise, the unit questions, yeah, okay, that's good. Now, another thing is like I figured out that h has to be 3. So if you plug 3 into any of these, you should get that they're equal to 10. So like for 13, if you plug 3, you'd get 69 over 60, which is not going to give you 3. So 13 minus something that's not 3 is not going to give you 10. 60h over 23. 3 is 180. Divide that by 23, and you will get... Did I say it's going to be... No, I'm sorry. It's not 3 hours. It's 3 gallons. It's 3 gallons. And if they're traveling at 60 miles an hour with 23 miles per gallon, how long is it going to take them? Oh, that's going to... Okay, yeah, 69 miles, exactly. 69 miles is how far they've traveled. If you divide that by 60 miles an hour, you get the number of hours. All right, I'll do that. Okay, so we said that 23 miles per gallon. We know that we spent 3 gallons. So we must have gone 69 miles. You want to figure out how long that would take you? So rate is distance over time. And we want to solve this for time. So we solve this for t by multiplying it over to here. And we have distance over rate. So it is 69 miles is our distance divided by 60 miles an hour. So this gives you how long your trip is going to take, which is it's going to be 1 and 9/60ths. So you can divide both those by 3, so you get 3/20ths, which is 0.15. So h has to be 1.15. So you can also plug that into all these and figure out which one of these is going to match, and that's going to be B. Okay, unit question done. Done. Let's make sure I'm going to ask a question yet. No, just not koozie. Awesome. Okay. I got to go get a haircut. I'll try to be back on time. Not koozie, should I just keep doing these and so you can watch later? I can keep doing these. I assume I have nothing better to do. Yeah, please. All right, yeah, you're good. Have fun at your haircut. Try to get more than one hair cut if you can. Goodbye, not koozie. This was fun. Okay. Here is the next one. Okay. Who else is watching right now? Say hi. Otherwise, it's just lonely. It's just me making videos for someone solving things. And I think that that's fun, but I want company. It's a big world out there. I'm just a small Brady working for an even smaller Nerdish. Well, say how if you want. The number of structures built in each decade in Denver County is shown in the histogram to the left. Data for years before 1940 or after 2009 was not collected. Which of the following statements about the shape of the number of structures built is true? Okay, number one, it's bell-shaped because most structures were built in the 1950 to 1959 decade. Bell-shaped is the bell curve. It is symmetric. It is the normal distribution. It looks like a bell. It's got a high center and it's got lower sides. This does not look like that. It is not a bell curve. I'll draw out a bell curve for you in just a sec so you can see what it looks like. A lot of things in nature end up following the bell curve. So like, you know, if you gather all the 15-year-old boys of the world and you record their heights, you're going to get an average height, and you're going to get that most boys are close to that average height, and then you're going to get that there are boys that are very far away, but there's not many of them. I can stay until 6:30. Right now, like, oh, you can keep watching. This is what a bell curve looks like. You convinced your mother. Oh, not koozie. That's nice. That's fun. All right. As long as you still get your hair cut. Haircuts are important. I am letting my hair grow right now, and it's in that awkward, messy period. And my mom is not thrilled. So your mom is really taking one for the team here. Anyway, that is what a bell curve looks like. Now, this is a perfect bell curve. If you actually find it in nature, it's not going to be perfect, but it's going to look something like this. You're going to have some, you know, there we go. Here we go. Maybe we'll get a little higher here, and then it starts going down a little bit. So it will roughly look like that. It's going to be roughly symmetrical. This is not symmetrical, so this is not a bell curve. Okay, bell curve is like a messed up parabola. Yeah, it does look like that. Yeah, and you kind of just kind of bent it outward at those ends right there. Good. B, it is bell-shaped because most structures were built in the 1970-1979 decade. Okay, so both A and B talk about when most structures were built. That's going to be the highest bar. The highest bar is from 1950 to 1960, which A has that in it, but it's not bell-shaped because of it. So B is also wrong because it's simply not true that most buildings were built in 1970, 1979. And you know, also, most buildings, like the highest bar is 1950, 1959, but that doesn't mean that over 50% of all the buildings were built in that decade by a long shot. There's a ton of buildings represented here, a lot of them. And if you're going to say most of something, that means that more than 50%. And 1959, 45 over however many buildings are represented here, which is probably a couple hundred. So most buildings were not built then. Most buildings were built across the whole time period. Just a large chunk of them were built in that time period. So that part of A actually is wrong. C, there is little variance in the shape, and D, there is a lot of variance in the shape. Okay. A little variance in the shape, there's a lot of variance. So variance means basically how much something is changing. So if there's a lot of variance, then it's kind of wacky and crazy. And if there's little variance, then basically every decade you should see the same amount of buildings built. If it was 20 every single decade, you'd have this nice rectangle. There'd be no variance. It just is always 20. This is pretty random. This is a lot of variance. That's why this ends up being D. Every year, you know, buildings go up, buildings go down. It's kind of interesting because this looks like it's buildings. That's what these bars kind of look like. Yeah, fantastic. We're going to continue. That's what we're going to do. All right. This looks like a good one. Let's just crop it a little bit. Just kind of crop it a little bit. All right, close it up a little bit. There we go. Didn't do much, but I just sort of get very satisfied by that whole process. All right. Here we go. The graph at the left in the AP plane shows P, the atmospheric pressure of Earth in pounds per square inch for a given value of A, the altitude above sea level in kilometers. The Earth's atmosphere has the property that there is a fixed distance d such that for any altitude a naught, the pressure at an altitude of a naught plus d is 1/2 the pressure at an altitude of a naught. What is the approximate value of d in kilometers? Oh, that's interesting. That's interesting. So a naught, that's that little 0 right there, okay? For any altitude, so like if you just pick any altitude and call that a naught, this pattern should work. So let's just pick an altitude. Let's make this a nice one to look at. Let's say this is 5, all right? So we're going to label 5 as a naught. So when you have that little 0 there, that's pronounced not. Not is an NOT. I'm pretty sure it's like not like this. I may be wrong though, but it doesn't mean like not a. It's just a sub 0. We say a naught. I guess it's because maybe it's like no value or something like that, even though it kind of is. That's just what that's called. But it's just one of the values of a, and it says for any value of a naught, the pressure at an altitude of a naught plus some distance is 1/2 the pressure at a naught. So any starting a we could pick, which is 5. There has to be a distance that we can add to get to 1/2 of our original pressure. So let's actually look at our pressure first, though. So at 5, if we go up to 5, we will find that the pressure is around 7.5. Yeah, it's around 7.5. The answers are all very far away from each other. So what that means is we can do a little bit of estimating. It's not going to be the end of the world. So I'll say at 5, it looks like it's around 8. So that is around 8 right there. So that's 8, and this is a naught right there, okay? So it says that there's some distance d, so that if we add that to our altitude, we'll get 1/2 the pressure as what we started. So what distance do we have to add to a naught in order to get a pressure that's half of what we started with? We want to get 4. That's the pressure that we want to get down to. So what distance do we have to add to get over to that point? Basically, what altitude do you have to be at to get 4 as your pressure? What altitude do you have to be at to get 4 as your pressure? Right, it's going to be 5. Yeah, 10, exactly. Yeah, it's at 10, so you have to add 5 in order to do that. So as it turns out, if you look at this, every time you add 5 kilometers to any altitude you start with, it goes down by half. You know, at 0, we're at around a little bit above 14. If you add 5, we go down to about 7-ish, 8-ish. So that's the first one. From 5 to 10, what we just did, we go from 8 to 4. From 10 to 15, you're going from 4 to around 2. Every time you add 5, you divide by 2. That's what this is saying. Good stuff. Good stuff. You know what? I should... Oh, where did this one? Here. I should be posting on the Discord right now. I forgot to do that. So, one sec. Here we go. Bam, bam, bam. Slam, bam. Thank you, ma'am. Have you seen that on the SAT? That altitude kind of question? Or this kind of thing right here? Where is the Discord? Which one are you asking about? A naught. Oh, well, I mean, yeah, like you see that notation. It's just a notation, that's all. It's just for some particular a value, which they called a naught, that's all. You don't really need to know how to pronounce it, but it just means for any a value, if you just pick one and call that one a naught, you know, then you can go from there. So it's like your starting value, kind of. If you have something sub-0, x sub-0, that's like your very first x value, is kind of how we use it. Yeah, I mean, in physics, it's used the same way. It's like initial value of something. Yeah. Okay. Ooh, I need to go to the bathroom, but Levi's not here. B of n is equal to 2 to the n power. A binary code word of length n is a string of zeros and ones with n digits. For example, 1001 is a binary code word of length 4. The number of binary code words, b of n, of length n, is shown above. If the length is increased from n to n plus 1, how many more binary code words will there be? How many more? Okay. Not how many times more, but how many more. Okay, so let's just, here's the thing. We could put in, there's the easy way, then there's the hard way. Here's the easy way. Let's just put in our own numbers and see what happens. So they want us to raise that n value to just one more. So why don't we first take b of 3, and then we're going to take b of 4 and see what happens here. So b of 3, according to the function, is 2 to the third power, which is 8. And then b of 4 would be 2 to the fourth power, which is 16. So we ended up with twice as much, which is 8 more. And it's asking, okay, we want the difference between those. So 8 is not an answer, but there might be something that represents 8. And remember, we just picked n of 3. That's what our n value just was. So maybe the fact that we went up by 8, that was our difference, has something to do with the n value that we picked. So which one of these n values would actually give us a value of 8? So we have 2 to the n power, which in this case is right. We have 2 to the n plus 1, which would give us 16, which is not true. And then 4 to the n power, which is 4 to the third power in this case, which would be 64, which is not true. So using our own values, we got that we went up by whatever this number was. We went up by that number, which is 2 to the n power. Okay, I am going to be right, but how would I know not to plug in 4 instead of 3? Hold on a sec. So basically, I'm putting my own values in for n. So they're asking us to compare b of n to b of n plus 1. So I decided, let's just call n 3. So if that's 3, then n plus 1 would be 4. And I need to go to the bathroom. Levi is not here. You wouldn't ordinarily know that I'm in the bathroom. So momentarily, just wait a sec. I'm coming back. Don't go anywhere, because I am back. I am back, and better than ever. Okay, so that was the easy way, which is put in your own values and see what happens. Then there's the algebraic way. Brady is back. Yes, he is. Now, Kuzi, it's just me and you. Levi's not here. Other students aren't here. You're getting quite the service right now. This is all for you right now. You should feel very special. So, if I were to redo this and not put in my own values, one-on-one tutoring, yeah, and then there's this whole board and stuff, just even better than what you usually get for one-on-one tutoring. I'll do it over here. So we would get 2 to the n, and we're comparing that to 2 to the n plus 1. And they're asking us, how greater is this compared to this, which we know means subtraction. How many more binary codes will there be? So we just subtract these two right here. This marker is not good. This marker is pretty good. Yeah, I'm going to keep using this. So we have to subtract those two things. And we know that 2 to the n plus 1 is bigger. We know that. It turned from 8 to 16. This question is, Skada! 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 What's going on? It's been a while. What are you up to, man? Just give us the lowdown. We're trying to do this. It has been a while. It has been. It has been a metric while, a binary while. 2 to the n plus 1. That's what you have to understand here. Who is Skada? Who isn't Skada? Most people. Exponent properties. X to the 5th times x cubed. You add the exponents. If you're multiplying, you get x to the 8th. All right? You can use that with actual numbers. Well, that's the whole point of exponents. 2 to the 5th times 2 to the 4th. Same base. We're multiplying, so exponent properties hold. 5 plus 4 is 9. So this is 2 to the 9th, okay? Bonus question. Skada or not Kuzi? This is for either of you. 7 to the 8th times 7. How could I simplify that? 7 to the 8th times 7. 7 to the 9th. Yeah, good. Exactly. So, instead of 8, let's just say I used x. 7 to the x power times 7. How could you simplify that? It is exactly the same process. No. JK, I don't know. Well, what did you do before? How did you get 7 to the 9th? You added, right? You added the exponents. There you go. Yeah. 7 to the x plus 1. Exactly. So if you have this to start with, you can break it up into the multiplication that it was before. You could go back to 7 to the x times 7 to the first power, because that's equivalent to this. That's what we can do up here. All right? We can take 2 to the n plus 1 and break it up into 2 to the n times 2 to the first power minus 2 to the n. It's so clear now. Ah, yay! Yay, I love it when it's clear. Okay, that's fantastic. That is fantastic. Wait. Yeah, we're not done. We still have a couple steps to do here. Don't worry. Why'd you do minus? Well, remember, we're trying to find the difference. Right, we're comparing b of n to b of n plus 1. So, oh yeah, exactly, good. All right, so here's what we want to do with this. We want to subtract. Both of these have 2 to the n in them. You know, we're just trying to simplify this as much as possible. Both of these have 2 to the n in them. So if I take that out, we have 2 to the n times 2 minus 1. 2 minus 1? Tindo! Everyone's showing up. This is excellent. 2 minus 1 is just 1 itself. So this is going to be 2 to the n. That is what the difference is between them. When you subtract, you end up getting 2 to the n because of all the steps that we just did. Ladies and gentlemen. Ladies and gentlemen. Gentlemen and ladies. Got it. Excellent. Excellent. Then we will continue. Any other problems yet? No, there are not. All right, here we are. This is pretty good, actually. This is already kind of in the right spot. Could just tighten this up a little bit. All right. So h is equal to x times v minus 5x. And I'll erase this. Okay, the equation shown above gives the height h in meters of a spray of water from a particular lawn sprinkler at a distance x meters from the sprinkler when the water is traveling at a velocity v in meters per second. You know, the kind of math that you do every day. The maximum spraying distance is the horizontal distance from the sprinkler where the water reaches the ground. If the velocity is quadrupled, how does the maximum spraying distance change? Okay, so we don't need to understand what's happening. We just need to understand what each of these variables is. That's it. That's all it is. We got a sprinkler. Great. Sprinklers are great, especially if you're trying to sprinkle. So let's write out this equation, and let's just label what each of these things are again. Prodvanix, my white compatriots. Interesting. Interesting choice of words. H is equal to x of v minus 5x. v minus 5x. Okay. So they tell us that h in meters of a spray water from a particular lawn sprinkler at a distance. Okay. So this right here is the height of the spray of water. I guess is how high that water gets off the ground. All right, height of spray. At a distance x meters from the sprinkler when the water is traveling at a velocity. Okay, so this is the distance away from a sprinkler. Distance away from a sprinkler. So this allows us to calculate how high the water is at any point away from the sprinkler. Because if you're sprinkling water, it's going to travel in a parabolic trajectory. You got a little sprinkler, and the water is going to come out like this. So at any point, if you find the x distance and the y distance, and that's the height right there. That's what they're explaining to us. I know I said, what are you talking about? I literally love sprinkles in my ice cream. Scotta! I miss your antics. I miss them. And I'll tell you that Levi does too. We talk about them all the time. So remember that shirt. What is it? You're, because two can do anything. Yes, two can do anything. Excellent. Excellent work, Scott. Excellent. I know I said we're not going to understand this. I guess I was wrong about that. Not that we need to understand it, but I'm just labeling. Okay, and v is the velocity of the water coming out. Okay, so velocity. Velocity. Okay, if the velocity is quadrupled, how does the maximum spraying distance change? The maximum spraying distance is the distance, the horizontal distance from the sprinkler where the water reaches the ground. Where the water reaches the ground. Okay, so when the water reaches the ground, it's gone the farthest it's ever going to go. And what's going to happen to this equation? How do we represent the water hitting the ground in this equation? Do we know the distance away from the sprinkler? No, that's what we're trying to find. Do we know the velocity? No, we know the height of the spray. 0. H equals 0, exactly. That is how we can start zooming in onto our eventual solution, is we know that we're going to calculate this when 0 is equal to all this stuff. 0 is equal to x times v minus 5x. And they're asking, what happens to the maximum spraying distance? So now that we set the set equal to 0, x right here is our maximum spraying distance. And as you can see, these factors actually tell us what x is going to be right off the bat. We have two factors, x and we have v minus 5x. Okay? The first one, this x factor would give us a solution, a root, an x-intercept, a 0, if you will, of 0 itself. X could be 0. And then from this factor, if we get v is equal to 5x, if we set it equal to 0 and then solve this for x, we get x is equal to v over 5. These are the two x values that allow our water to be at the ground. The reason why we have x equals 0 is because at the very beginning, right when it comes out of the sprinkler, that very first instant, it is still at a height of 0. It's because it's right at the ground. So it hasn't traveled any distance yet. So we do have a height of 0 at the very beginning, and then we have a height of 0 again at the very end when we hit the ground. So that's two different places. X is 0, and then x equals v over 5. We're almost there now. Not koozie. Wow. I know. Mind-blowing. Mind blown. All you need to know is v minus 5x. Yeah, that's where this is going. That's all you need to know, right? Velocity is quadrupled. How does the maximum spraying distance change? So our maximum spraying distance right now is equal to v over 5. If this is quadrupled, then x is going to be quadrupled. Yeah, I mean, all you really need to understand from this right here is that this is a directly proportional relationship. X is equal to something times v. It's in this form. This right here is directly proportional. If something is equal to some constant times some number, it's directly proportional. So if v doubles, x is going to double as well. And in this case, yes. If this is quadrupled, if we want to make this thing 4 times bigger, it would give us 4v over 5. Here, wait. So we're going to say x1. X sub 1 is that. That's when it's normal. And then let's figure out what x sub 2 is if we multiply this by 4. 4v over 5. So how many times bigger is x sub 2 than x sub 1? Well, it's become 4 times bigger than that. Yeah. The difference would be if we had something like this. If v was on the bottom and v was quadrupled, then x would be 1/4. Because this bottom number would be 4 times as big. So we're dividing by a number that's now 4 times bigger, which means we're going to be 4 times smaller. Or if you had something like this. 5v squared. If v was quadrupled, what do you think would happen to the value of x? Not koozie, this question is yours. If it was x equals 5v squared, 16, you got it. Yes. But this is a simple linear relationship right here. Good. Love physics. Love it, love it, love it. Big fan. Big, big fan. Oh, knit. Okay, so here's what we're going to do. Kooz has one more question, but Knit has now submitted some questions. So we're going to... Oh, you got a blast. All right, fine. Knit's going to be here for a while. The last one, because you have to blast. Sorry, Knit. We'll get to your questions in a sec. Then you're all... I'm all yours. Sorry, I was going to say you're all mine, but that's not true. I'm all yours. Go. Okay. Sorry, Knit. Sorry, Knit. He's got a haircut. Haircuts are important. This will be quick. I'll make it quick. The histogram to the left summarizes the measurements a botanist made of the transpiration rates in millimoles of waters per square meter per second of several diamond leaf willow plants. In which interval does the median transpiration rate occur? The median splits the data in half. On a histogram, it tells you how often a certain thing happened. So the number of plants that were between 0.5 and 0.7 is 1. That represents one plant right there. All right, the number of plants between 0.7 and 0.9 is 5. So we just have to count up how many plants we have here. So we have 1 plant plus 5 plants, so that's 6. Plus 3 plus 3, which gives us 12. Plus another 5, which gives us 17. Plus 1, which is 18. Plus 3, which is 21. We have 21 plants represented. In order to find the median, we have to go to the middle number, which would have 10 on both sides. 10, 10. The one in the middle is our 21st. So we have to count 10 from either side, and we'll get to the median. So we count from the first side. We get from there to there would be... I'm going to make this... Hold on. There we go. Okay. So from here to here is 1 plant, and then from the next one we get 5. So total, we've got 6 plants so far. And then with this next one, we're adding 3, which is 9 plants. So our 10th plant is going to be somewhere in this column, which means our 11th plant will also be there. The 11th plant is the median. You go from both sides by 10, and it's the very next one. So what is that in there? That is from 1.1 to 1.3. That's where your median is going to be. All right, Nakuzi, make sense? If so, get out of here. Okay, good. Tindo, you're up. All right. Here we go. Here we go. this as big as possible. Very good. Very good. But the answer looks weird. Sorry, I didn't even look. Hey, don't worry about it, huh? Hey, forget about it. Huh? Forget about it. Forget about it. F of x is equal to 2 to the x power plus 1. The function f is defined by the equation above, which of the following is a graph of y equals negative f of x in the xy plane. Transformations. What we first have to know is what does 2 to the x plus 1 look like? And then what would be, thank you, Braid Boy. You're welcome. May your land be blessed with abundance of harvest and your townspeople with great fertility. That's what people want, right? Let's start with this for a sec. This is a transformation. Your y value will be what it used to be, except everything is multiplied by -1. Remember that f of x basically means y value. F of x is the output of a function. I got 3 questions wrong. I got 760. Ah, okay. 760 is, you don't like the curve. Hey, man, 3 questions wrong out of, what is that, 55? I mean, 20. No, it's 58 questions. That's really good. Now, are these from that? Is that what these are? I'm assuming that these are probably from that. Yes, they are. Okay. So if we're taking our old y value, this is the output of the function before, and we're multiplying by -1, this is going to make all of our y values the opposite of what they were before, which is going to be a vertical flip. It's going to take everything, it's going to flip it vertically. All right? Everything, I mean, like this, you do this and all this stuff. This is a vertical flip. Okay? Or a vertical reflection. That's actually probably, that's probably the better one. It's a vertical reflection, not a flip. I mean, it is a flip, but I think reflection is the better word. And you could think of that as over the x-axis, which is a little counterintuitive because when you think x-axis, you think left and right. The x-axis does go left and right, but if you flip over it, you flip over to down or up, okay? That's what this does. So what we have to do is figure out what is 2 to the x plus 1 even look like, and then we can flip it over. So there are parent graphs. 2 to the x, or just some value to the x. Probably a good parent graph for you to know. We'll start with that, then we're going to add 1 to it. But you can always just on the fly, you can put it in your calculator's grapher, or if this is on the no-calc section, then you just have to figure out what the graph looks like. You always have a table of values that you can just try some values on and see what you get, okay? If x is 0, 2 to the 0th, y is going to be 1. If x is 1, y is going to be 2. If x is 2, 2 squared is going to be 4. All right, and then I'll probably want to go backwards by 1. Well, let me go 1 more. If it's 3, it's 8. So we're multiplying by 2 each time. Okay, I'm going to put these up. So we have, 0, 1, sorry. That's right there. 0, 1. We have 1, 2, which looks like that. And we have 2, 4, which looks like that. This is exponential growth. And if you go backwards, so if you have x equals -1, then it's going to be 2 to the -1st, which is 1/2. So it's going to keep dividing by half if you go to the left and keep multiplying by 2 as you go to the right. So your graph is going to look something like this. All right, fantastic. This is great. But it's not 2 to the x, it's 2 to the x plus 1. This is a vertical translation of +1. We are going up by 1. So everything is going to be actually 1 unit higher than I just drew it. So here, I'm going to now redraw. Everything is 1 unit higher. So that's going to be right here. That's going to be right here. Okay. So that right there is 2 to the x. This right here is 2 to the x plus 1. That is the one that we have to do a vertical flip or a vertical reflection over. Okay. So just some points here. If we do that, it is going to be going like this. If you just think of x-axis as a mirror, it's going to be going to the right and then downward. So A is wrong, as is B. It's C and D. Those are the correct ones. But now we have to figure out, which one is going to be correct. I'm going to erase 2 to the x plus 1 now, because we used it to find what 2 to the x... Sorry, I'm going to erase 2 to the x. If you reflect this thing, just like when you look at yourself in a mirror, if you're 1 foot away from the mirror, you see a reflection of yourself that's 1 foot away from the mirror. It's weird. If a mirror is really nice and clean and polished, it doesn't even, like the fact that it's a mirror, it's not even a mirror. You just see the world going that way. Like it just looks like it's the world, but it's a weird copy of the world, which is, pretty wild if you think about it. But anyway, a foot away from the mirror, your image is 1 foot behind the mirror, hypothetically. So this thing here is going to be down here now. This thing here is going to be, so what was that, 1.5? Now it's going to be at -1.5. This thing here was at 3, now it's going to be at -3. That's what this is going to look like, which is going to be C. We do not cross the x-axis. So D is wrong. That's why it's going to be C. Tindo, how we doing? Make a sense? I'll go to the next one. I thought 1 is the y-intercept. Oh. Well, on 2 to the x plus 1, if you just did 2 to the x, 1 is the y-intercept. But 2 to the x plus 1, oh, I see what you're saying. That's what you thought, and that's why you got it wrong. Okay, so you forgot to take into account that it was the vertical translation which brought it up to +2 and then down to -2. I get that. I get that. Yeah, this is a step-by-step process. Say a step-by-step process. But also, if you want to think about it like this, we're just taking our old f of x and multiplying it by -1. So this new one is going to be -1 times 2 to the x plus 1, which is going to turn it into -2 to the x minus 1. And if you want to find the y-intercept of that, then you put 0 in for x. So -2 to the 0th, which will be -1, because you do the exponents first. So 2 to the 0th is 1. -1 minus 1 will give you -2. And then that's one way to figure out what your y-intercept is going to be. And actually, once you know that, C is the only one that is the correct y-intercept. So that, I think, is a shortcut. I explained the whole thing just so that students can see what all the different facets of this problem are. But if you can find the y-intercept immediately, then you're good. Yeah. Okay. Here we go. I have a feeling Levi is here. I feel like I just heard him. Someone's moving. Someone's scurrying about upstairs. I don't know who it is. All right. Here we go. Let's get rid of that stuff. Okay. A polling agency recently surveyed 1,000 adults who were selected at random from a large city, and they asked each of the adults, "Are you satisfied with the quality of air in the city?" Of those surveyed, 78% responded that they were satisfied with the quality of air in the city. Based on the results of the survey, which of the following statements must be true? Keyword being, hey, Levi's here. Keyword being must be true. Some of these could be true. Levi's behind. He's in front of me. I know, don't worry, I see him. But they're not necessarily true because they have to be. They just might be. Okay, so they did a survey. They didn't interview everyone in the city. They just interviewed 1,000 people and hope that the survey is representative of the whole population, but they can't know exactly how representative it is. Hopefully it is around 78%, but we don't know. Of all adults in the city, 78% are satisfied with the quality of air in the city. That might be true. It doesn't have to be true. Samples are rarely 100% accurate. The chances that a sample that you take is exactly accurate to the whole population is incredibly small. All right? It's probably around 78%, maybe somewhere between, 68 and 88%. But saying it must be true is wrong. It doesn't have to be true. If another 1,000 adults selected at random from the city were surveyed, 78%, is it plausible, I guess? It's plausible, but the key word is must be true, okay? It could be true. It doesn't mean it must be true. In fact, it's probably false. It's not even likely. The likeliness that your sample is the exact same statistic as your population is very rare. It's the best guess you have. But that's why we use what's called confidence intervals. So in like statistics, you know, you take a sample of a whole population and you say, we're going to guess that it's around 78% of people that are likely to, or that are satisfied with the air. But we have this confidence interval, which is, and you'll learn about this in statistics, but maybe it's like we go up 5 and down 5. So this goes up to 83%, and this goes down to 73%. They might say something like, we're 68% confident that the real statistic is between 73% and 83%. So our guess is 78%. That's the best guess we have, but like we don't know for sure. But we do feel pretty confident that it's between 73 and 83. And you can extend that further. If you go 5% more in both directions, here, wait, I'm going to make this like this. This is going to be 68, and this is going to be 88. Then you can get a 95% confidence interval. This is just, you'll learn about this in statistics. So you're like extremely confident it'll be between 68 and 88. You just don't know where, all right? That's why it's plausible, but we don't know for sure. Another 1,000 adults selected at random were surveyed. 78% of them would report they're satisfied. Doesn't have to be true. You take another sample, the probability that you get the same exact rate is quite slim. In order to get 78%, you got to get 780 adults out of 1,000 to say they're satisfied. What if you get 781, you know? Like, your sample should be as large as you can make it, as large as you have resources for, because if you only interview one person, and they say, yeah, I'm satisfied with the air of the city, you'd conclude, okay, 100% of the people in the city are satisfied. That's a terrible sample. One person? Not enough. You have to randomly sample people from all around the city. There might be certain parts of the city where there are factories nearby. Chemist. Chemist, we'll get to that in a sec, okay? So the fact that, does this have to be true? No, it does not. And then 3, they're going to a different city. If you're in a different city, all bets are off. They have different air quality. So like saying that 70% of them, like, you know, if you took this first one in San Francisco, then you went to Beijing and was like, oh, well, 78% of them in Beijing will also say that they're satisfied with the air. No, not at all. In fact, I'll tell you for sure from experience, that's not true. Although I hear it's a little bit better, but no, it's not true. So none of these must be true, which is why the answer is none. Levi.
Hello, sweet learners.
Scott actually showed up for a little bit.
Really?
Yeah.
I missed Scada?
He had some funny things to say.
I'm sure he did.
So Chemist just said some stuff.
Is this unrelated to your question that you were just doing?
Yeah.
If negative k plus 78 equals 98 minus 20 minus k plus 78 equals 98 minus... Why are there so many equal signs?
Yeah,
You gotta
Chemist,
throw some commas in there or something.
Chemist, we can't... I mean, KK... Is that like a... Is that like a KKK thing?
Or maybe they just didn't want to write k cubed. I don't know. Regardless...
Who?
What's happening?
Chemist... We don't know what that...
I think that's chemistry, so we don't know what that is. You don't do chemistry, and I don't do chemistry.
Yeah.
Never
Chemist, send us a picture of the question. Put it in our Discord. It's very difficult to type out a question like that. It's hard to...
For a chemist.
For a chemist, exactly. All right, we have 2 Willy questions.
Okay.
These are all you, dude. Yeah, of course.
They're all mine.
Let me set this up for you. I think you're gonna love
Thanks,
it.
Bird.
Yeah, of course.
Oh, it's both of them.
Hold on. Close.
Sweet chemist.
Yeah.
So we'll pull this up, and then we'll have to go to the questions after, which might be a little bit of an annoyance.
Levi.
Bird.
I hate that.
Thanks.
It'd be cool if we could pull up 2 windows at the same time.
No.
Maybe someday.
Okay, can you make it full screen? Thank you, sir.
Of course. I was hoping you'd never ask.
Okay, so when a patient receives a penicillin injection, the kidneys begin... Could you give me my markers, actually?
What?
Can you give me my
markers?
markers?
Sure.
Thank you. When a patient receives a penicillin injection, the kidney starts removing the penicillin on a certain, schedule. Great. Thank you, Bird. The table and graph above show the intervals over 20 minutes immediately following the one-time penicillin injection. Okay. That looks like penicillin concentration in micrograms per milliliter. Okay, I assume this is not a unit conversion question, so I don't really care about that. And then the table seems like it's just the values that are then in the graph. Cool. Okay. And then the question. Chemists put it on tech and math in the Knowledge Fellowship. Bert, go to the Knowledge Fellowship and then maybe you can find it.
On what? On Discord?
Yeah, the Knowledge Fellowship Discord.
Okay.
Okay, so according to the table, how many more micrograms of penicillin are present in 10 milliliters of blood drawn from the patient 5 minutes after the injection than are present in 8 milliliters of blood drawn 10 minutes after? Okay, got it. So we have
which channel on?
tech.
Tech.
Yeah. So 10 ml of blood at... So there are a couple things that we have to deal with here. 10 ml of blood at 5 minutes versus 8 ml of blood after 10 minutes. 8 ml of blood at 10 minutes. Okay. I think that we're going to have to do some proportions here because we don't have the same amount of blood, but there is a different concentration. So that the graph, which I will pull up again, deals with concentrations of blood. So in, let's see, per milliliter. Got it. Okay. So if we have 10 milliliters of blood and we're at 5 minutes, that's going to be that second dot in the graph, and it'll be the second line of the table. So we have, let's do it in another color. We have 100, oh, I should actually use the exact numbers, I guess. 152 micrograms. What is micrograms? Mg?
Yeah, little
Okay.
mg.
Micrograms of...
No, it's not. It's
No,
not
it's not.
mg.
That
It's
doesn't make
the little u with a tier. It's mu.
Oh, the mu one?
Because that's milligrams.
Yes, that's what I thought.
Yeah.
Is it not mass grams?
What? There you go.
Micrograms of penicillin, so we'll call that P. Okay? So we have 150, and this is per 1 ml of blood. So if we have 10 milliliters of blood, then we have to have 10 times as many as this number, if that makes sense. Or you could use dimensional analysis, do 10 ml times this thing, the mLs cancel out, you get 10 times 152. So we're going to have a result of 1,520 micrograms of penicillin. Yeah? Please let me know if that doesn't make sense, Will, if you're here.
Chemist is all good. We don't need to do anything.
Chemist is all good. Great. Glad you're all good, chemist. And then we're told 8 milliliters, oh, we don't care about that, at 10 minutes. So what is the concentration at 10 minutes? The concentration at 10 minutes is 118. So we have 118 micrograms of penicillin per 1 milliliter of blood. You got it, good. And then we just, we do the same thing. It's going to be 8 times 118 in this case, which is 800 times 18, 880, 944, I think. I may have done that math wrong in my head. Micrograms of penicillin. So I think the question was how much more is this than this? It's to do that subtraction. So it would be 576, I think. I think that was the answer. That's the answer. Not sure. Okay, so that's how you set that one up. Going forward with this type of thing, this is a big bundle of different concepts, I guess. I mean, you really have to be able to read a very, very simple table or graph, and that's pretty doable. And then after that, you have to be able to do dimensional analysis or set up a proportion. The proportion, which I actually didn't set up, would be we have that per 1 milliliter of blood, so now we have 10 ml of blood, so what would that be? We solve for x. So you can set it up either way. Okay, 38, I guess I might as well do because I'm here. Penicillin concentration in micrograms per milliliter in the patient's bloodstream t minutes after the penicillin injection is modeled by the function. Okay, so this is our function where P is the values in the table within 10 micrograms. What is the value of B? Where's B? Oh, yes. Okay, and then it's T to the, or over to the T over 5 power. Okay, so we're going to have to set up some equations here. Let's get rid of this. We don't need that. We don't need this. We don't need this. We really don't need, I mean, we could use that information. No, we can't. No, that's not useful either. Okay. Everything goes. Hey, Bird. I'm proud of you.
Why? Just in general?
Just ask Jane. Hi. Hello. You come to the wrong place if you love math. That's actually not true. But you've come to the right place regardless of how you feel about math. Wait. Are we asking you something, Jane? Is that the goal here? I'm happy to do this one. I don't know. This is sort of math. It is math. Okay. Thanks, Bird. That's great. So we have P of t equals 200 times b to the t over 5 power. That's our equation. We have 3 variables at the moment. We have p, we have b, and we have t. Now, b is a constant. We have to figure out what it is. We can always find that constant if we have a data point to plug in. So let's just do that. Oh, very good. Continue watching our math excitedly. That makes me excited. Bird. Ow. Sorry about your ears. I just smacked the microphone.
What happened?
Just Ask Jane is here from the Knowledge Fellowship. Very exciting.
The Knowledge Fellowship.
Yeah, you really brought that one home for sure. Okay, let's take some values from the table. I forget what the values are. Let me just find one of them. It doesn't really matter which one we choose. Let's try to choose one that's pretty easy. Let's do 0 to 100. That seems easy enough. That's not going to help us. Yeah, so the idea of picking 0 to 100 is nice because those are easy numbers, but it's not actually going to help me do anything with b because we plug in 0, this would be t, and this would be p. But plugging in 0 for t makes this to the power of 0, which means that we can't figure out what b is because b to that power would be 1, so it's useless. Great, so thanks for nothing. Let's do 5/152, that's fine. Actually, that's ideal. Let's do 5/152. Okay, so if we're doing 5/152, we're going to get 150, nope, I don't want to do it that way. Height, yes, there's lots of height. Cookie, are you still feeling good about this? Are you following along to this point? Do you know exactly what I'm about to do? In which case I could stop. I won't because it's already begun. I can't stop. So we're going to plug in 152 for P, and then that will equal 200 times B. Still don't know what B is. Now T is going to be 5. So I picked this one because now we'll have 5 divided by 5, which is very simple, just 1. So now we have 152 equals 200 times b to the first. So we don't care about the first power. And then let's divide both sides by 200 to solve for b, and we get whatever 152 over 200 is. Okay, you kind of get it. That's perfect. That's all you need. Kind of getting it is enough. I'm just kidding. 152 over 200 is about 3/4. So I'll stick with that for this one. Okay, what part of this is tripping you up, Cookie? We have this information in the graph here. They gave us this equation, but they don't know one of the pieces of it. because the equation, when you're making the equation for this graph over here, you want two variables, right? You want your x and your y, or in this case, your t in terms of time, and then your concentration p of penicillin, right? But we have this third variable. It's not a variable. It's just it's a constant we don't know. Because of that, we need to solve it. We can solve it because we know that this equation has to represent the data in that graph. So we plug in one of the data points for t and p, and then the equation has to work so we can solve for b. This is exactly the same concept, honestly, as saying y equals 2x plus b. And we know, and so there's a totally different scenario, but y equals 2x plus b, and we also know that this graph passes through the point 1, 4. Right? If we know that, then we can solve for b by plugging in 1 and 4 for x and y. We get 4 equals 2 times 1 plus b, so we know that b equals 2. So now we know that this equation will actually be y equals 2x plus 2. It's the same idea here. Does that explanation clear it up for you? Got it. Good. Awesome. Okay, Bird, it's so hot in here. What are we going to do?
Oh, Levi.
I guess I was kind of confused on how to convert t and p from the graph to the equation. Yeah. I mean, at the end of the day, and this is the hard part about complicated scenarios like this, is that they kind of take you away from the basics of what's going on. The basics of this is you have a graph and you have an equation. They represent the same information. By definition, the equation of a graph has to, it gives you the points on the graph. So the points have to satisfy the equation. And that's from 10 years ago when you started, not 10 years ago, but what grade are you guys? Like at least 5 years ago, when you first started doing equations. Or when does algebra start normally, Bird? Like 5th grade, 6th grade?
No. Let's see. For me, I started in 7th grade.
7th? Yeah, in earnest, it definitely starts in middle school. I remember learning about x in 5th grade though, with pawns. We used pawns, and they could be anything.
Pawn?
Like a pawn.
From a chess?
Yeah, we had these scales, and then we were putting pawns on the scales, and we had to count stuff.
Oh.
It's like X, but it's a pawn.
Right, that makes sense.
Yeah.
I like that.
And it helps everybody else when I talk about it. A lot of people start pre-algebra in 9th, though. Yeah, but anyway, I don't know what I said, but whatever it was, it probably wasn't particularly useful for anybody. Okay, I think do we have more questions, Bird?
I don't know.
You don't know?
No.
Did you do all of these Koo's questions?
Yeah.
Oh, did you do Nit's questions?
Yeah.
Nit.
Yeah, we're good.
Maybe. Okay. Maybe I can pull something off the SAT or ACT Discords. No. Not there, sir. This looks fun. Yeah, let's do this. Hey, Bird.
Yeah.
Actually, I'll do this one. You seem very comfortable.
You don't know that.
I do. All right. So this is a question from the SAT Discord. See how this goes. Okay, so in this question, we're given f of x and we're given g of x. This is function notation stuff. This thing over here, this g circle dot thingy, I don't know what that's called to be honest, of f. That does not mean g times f. What that translates to, and this is what it means every single time, is g of f of x, like that. This means g of f of x.
Oh, yeah.
That's what that means. Oh my gosh, that was stupid. I thought I was in the right place.
Oh, Levi. We could always just shorten the...
No, impossible. Okay, so we have that. Just ignore this. Dang it. This is going to be... Thank you, Bird. This will be g of f of x. That's what that means. Okay? Now, I'm going to write this in two different colors to demonstrate what has to be done here. You have to do G, and then whatever you put in the parentheses, you input there. What's going on?
I think the color makes it look like it says of.
Oh, I see. Got it. Lovely. And now we're going to do f of x in here. That's what we're plugging in for G. Now, we're just taking f of x. We're just taking that thing, right? Whenever you have something like, I'll do this in yellow just because it's totally, or it's a different thing. If we have f of x equals 2x plus 1, and I say, what is f of 3? Then you have to plug in 3 for that x, right? So we're doing exactly the same thing here. But rather than plug in something like 3 into this equation, we're plugging in all of f of x, and any x in G's equation, we plug in f of x for that thing, the whole of f of x. So let's get that started. So G of x, oh boy, this is going to be a little ugly. So this thing will be, let's start it here, G of G of f of x will be, let's do this, so G of f of x is 2 over 3x minus 1. And G of x is that x plus 4 over x. So every time we see x, we replace it with 2 over 3x minus 1. So we'll get 2 over 3x minus 1 plus 4 all over 2 over 3x minus 1. Okay? Now, from here, we just have to solve it like anything else. We have to simplify this pretty ugly thing. But I've lost my marker caps, so that's pretty upsetting for nobody except for me, to be honest. Okay, there we go. All right, so first we have to find a common denominator up top, and that would be 3x minus 1. So this will be equal to, I'm going to do this quickly because this is not the point of the question. 2 plus 12x minus 4 all over 3x minus 1. And that's going to be all over 2 over 3x minus 1. So this thing, I'll bring it up here, will be 2 minus 4 is negative 2. So we have negative 2 plus 12x over 3x minus 1. And we're going to multiply by the reciprocal of this, right? This is dividing by a fraction, so we keep change flip. So we get this guy times, we flip that, we get 3x minus 1 on top over 2. Well, the 3x minus 1s cancel. And then when we do this, we'll get negative 1 plus 6x, or 6x minus 1. And that should be your answer. I took this from the SAT, so nobody knows. I'm going to post it there. There you go. AC times BD. Careful. This reminds me of building nested formulas in Excel. Yes, it's just like that. Wait, how did I... Okay, that was gone before. Okay, careful, Cookie. This is not... If you're thinking about cross-multiplying, that's not what's happening here. I'm not sure if that's what you were saying, so stop me if that's not at all. If you're saying A over B equals C over D, and then you do cross-multiply, you get AD equals BC, this is true. That's not this situation here. We have a fraction times another fraction, so you just multiply across. I canceled these out because they're both on the top. One is on the top, one is on the bottom, so they'll cancel out. This is not the same thing. This is an equal sign, this is a multiplication sign. You're doing different stuff in these situations. If there's like A over B over C over D. Yeah, sure. Sure. Yep, I agree. All right, Bird, can you erase this so I can post this link?
Oh, absolutely.
And then you can do the next thing, whatever that is. It'll be super fun. I'm sure you'll like it.
Do you think so?
Yes.
Gee, I'd like that. Levi Jennings is on your side. Almond breeze is where it's at. Drink almond breeze. You know you want to. What am I doing, Leo, besides erasing?
That's it. Just keep erasing.
All right, well, I'm in the process, so I can continue. Weishima is on your side. Gotta let it dry. And it is dry. So Levi, I did something bad today.
Yeah?
Yeah, you were gone, and I was, streaming, and then I had to go to the bathroom. So
Did you start your own tutoring company?
Yes, today I did
Or
that.
did you just leave the stream?
I wrote BRB, and then I just walked away. I had to go. I mean, there was no getting around it. I had no idea when you were going to come, so I left. The most boring stream on Twitch that there's ever been. A black screen with a schedule, BRB, and no one behind it. It's very sad.
Who is this? Roby Expert. Hi, Roby Expert. Ruby? Roby.
Roby, it's Rob.
Rob.
Yes, indeed. I know. I don't feel good about it. In case you think I do, you're wrong. I don't.
Very nice. Let me see if there are more questions we can do.
I think that'd be a good idea to see if there are more. Because if there are, then we could do those questions.
That doesn't make sense.
Well, that's why I thought it'd be a good idea. For the stream. For the war effort. Doing SAT during summer break. That is exactly right. Roby.
There's an SAT on August 24th.
There's an ACT on September 14th.
And there's an SAT on the next month.
Like 2 months away from the SAT, the first one?
Yes.
Yeah. There's 7 of each for a total of 14. They make sure not to do it on the same
So it's
weekend.
one every month.
Yeah.
Exactly one, no more, no less.
It's a duopoly, isn't it?
I don't know what that is.
Think about it.
Okay.
Duopoly.
So, do what?
Well, yeah, there's that.
That?
You can figure it out. What does it sound like? Context clues.
Oh, no, Bird.
I don't want to... You get both of them. You get both of them. That's one. Yes, that's right, Roby Expert. Monopoly +1. A duopoly. Good. Just like the aircraft construction companies, Airbus and Boeing. Just them two. Any other big companies that make passenger airliners?
Yes.
Which ones?
Nerdish. You're flying on Nerdish Air.
Oh, no.
Oh my gosh. Please remind me of inhaling that word after stream. I gotta tell you about it. It's so funny.
Oh my gosh. Guys,
Stop it, Bird. I hate
you guys are
so
going to miss
much.
out. I'm going to know all about it. Why do you hate me? You might hate me, but do you like me?
It's your personality, Bird.
I can't get rid of that. I've tried.
You tried to burn it out,
I did.
and all you succeeded in is losing your kidney.
Yes. Can you guys go over multiplying roots? Ha ha ha!
Can you?
Multiplying roots, like factors into a polynomial, the multiplicity of roots,
Dividing
roots.
Oh, multiplying,
Ooh.
dividing roots.
Are you talking about polynomial long division, synthetic division? Are you talking just planting, like taking roots from the ground and dividing them? Is this a theater major?
Yes. Are you?
What is this?
No. We don't understand Cookie at all.
We never do.
I've never understood Cookie.
Yeah, we never will. That's not true. Roby Expert, is that a theater major? Tree roots. Oh. Yeah, if you have 5 roots and you multiply it by 10, you'll get 50 tree roots.
Yeah.
Yeah.
Which is 1/5 of a Nerdish root.
That's right.
Which is the basic building block for the polymers that make up the atoms that doesn't make sense. That make up
polymers that make up the atoms.
Nerdish planes.
Well, yeah, if you go down to the small enough level, the quantum realm, it's all nerdish.
Things start getting bigger.
Yeah.
If you push through to the smaller and smaller
Suddenly
things,
it's huge.
things get much larger.
Yeah. Cookie, you're gonna have to be more specific. Like,
Yes.
can you give us a problem that involves that, or can you just say like, oh, how do you multiply x plus 5 times x minus 7? Is that what you're talking about? If not, forget about it.
Jeez.
What? I'm trying my best. Forget about it.
You're not trying your best.
That's not true.
Okay, it depends on what you're trying your best to do.
I'll see if I can find one. Roby, where did you hear about us? What are your majors? Well, we are both out of college, so the correct would be, what were your majors?
And the answer is nerdish.
We majored in nerdish.
Yes.
Now, I majored in engineering.
I did major in theater, actually.
So this is a theater major right here.
Yes, that is that me.
This is not. But I did a lot of theater because I love it.
Oh, do you?
I'm a fan of the theater. What can I say?
I'm a patron. No, I'm not, actually. I don't
No,
have the
you're
money.
a willing participant
Yes.
of the theater. I can tell. I can tell. Hey, what's that supposed to mean? You can tell?
Does it mean we're overly flamboyant and histrionic?
Are we dramatic? I'm insulted.
Do you feel like we're not being genuine at times?
Do you think we're not being authentic for you? I kind of just said what you said.
Because I feel that way.
Yeah, I generally feel like that way as well.
Yeah.
So you're probably right.
The red dot has returned.
Oh my gosh.
Nobody else can see it. It's just us. All right. Hey, you guys got to ask us some questions.
Hey, what
'cause,
time? What time we got?
It's 7:26.
You guys have 4 minutes. Count them. 1, 2, 3, 4 to ask us 4
Clips, Twitch, average,
Caring
Caring
hamster, prime, me.
me.
I doubt that's something that is a question.
That seems like a question.
Hey,
So we're finding the average of Caring, Hamster, Prime, and me. So we have to find maybe the mass of each of those things.
it's a clip.
You're a clip.
It is a clip of you guys.
I
Well,
doubt it.
Here, let's find a clip here, and then we'll open it up there. We can watch
That's
it.
not possible.
Are you sure?
Oh yeah.
Oh no, it's totally possible.
Oh no, it's not. Do you need me to spot you while you do this or no?
I
What if you
can
fall?
get a spotter.
Yeah.
All right. This is absolutely.
you're
Stop,
so funny.
Levi. No.
You're so annoying.
What do you mean? How am I annoying?
Oh, I mean, we just did this.
I don't remember that.
Don't post it in TFK.
What does this
Whoa,
say?
this is gonna be super weird.
I can't get rid of that. I tried.
Yeah, that's the name.
Oh, my personality. That's what they're saying. Oh no.
Wait, Bird. We should put it in between us. No. We gotta watch us do it.
Uh-oh.
Bird, make it
Wait,
smaller.
wait.
No, Bird.
What?
Make it smaller so we can look at it on screen.
Okay. Oh, jeez. I'm just blowing it right
You're
now.
a doofus.
All right, right here?
I don't know. Fine.
All right.
I don't know if we can hear it though.
I can unmute it.
No. But the video won't actually play with sound.
I know.
Please remind me of inhaling.
You
after stream.
I forget what I said. Here.
Oh my
yes.
gosh.
Oh.
I'm the best tutor.
You guys are
Oh,
gonna miss out. I'm gonna know all about
Look
it.
at me erasing. Look at me erasing. Look at me erasing.
You might hate me.
Oh.
It's your personality, Bird.
I can't get rid of that. I tried.
Is that what you said there? I think that's what you said there.
You tried
Bird,
to burn it out.
Get rid
I
of
did.
your.
Always succeeded.
Have you found your personality?
Yes. Can you guys go over multiple
I clipped you.
numbers?
You got a little thing you just did. I'll post in
Can you?
TFK. Sexual harassment at work.
Multiple.
Not a
Please
troll
remind me
Suze.
of
Wait,
inhaling
what's
that
sexual
word
harassment at work?
after
I
stream.
have no idea.
Oh my gosh.
Okay.
Guys.
Stop.
Anyway,
Is that what's
You guys are
happening?
gonna miss
What's a
out.
hard
I'm gonna know
question
all
from
about
the
it.
SAT?
Why do you hate me? You
Um,
might hate me, but you.
I'll give you a hard question from the SAT. You know
I
where?
can't get rid of that.
Right on the
On the
whiteboard.
board.
Yes.
very good.
Haha.
What's a hard question from the SAT?
What time is it?
Yes. Can you guys?
What's a hard question?
Oh no, we have 30 seconds.
We only have 30 seconds to answer this question.
Please remind me of
What's a hard question?
inhaling that word.
Oh jeez, I don't know. Maybe the remainder
Stop
theorem.
it, Bird. I hate
You guys are gonna
so
miss
much.
out.
Who
I'm gonna know
are-
all about it.
You.
Um,
That's a hard.
That is a very hard question.
You might.
I mean, how do you define what you are or who you are?
It's your
We don't know the
personality, Bird.
questions on the SAT. We only know the answers. You have to
Tried
give us
burn
the
it out,
question.
I did.
And all you succeeded in is losing your kidney.
Yes.
Is the
Can you
video
guys go
still
over multiplying
repeating?
Yes, it is.
Ha ha ha.
Can you?
Can you hear it?
Multiple.
Please remind me
No,
of
they wouldn't be asking
inhaling
that.
Can they?
They can hear it? Interesting.
Oh,
Very interesting.
that's extremely strange. We could. Well, that's because we don't have any speakers on our computer.
Well, I know, but I didn't know that it picked
So we
up
could.
this.
Oh, there's so many possibilities.
There's literally no possibilities here.
No. There's all the
No,
possibilities.
Brady, there's no possibilities.
What are you talking about?
When you burned out the Horcrux of your personality and you died and then came back, there are no possibilities.
Well, maybe.
No. Bird, no.
Maybe. Should I say it?
Whatever you're about to say, I don't think is a good idea. The S does not stand for standard. Yay, learning. What's the sorry for? Wow. We don't understand this because these are not SAT questions. That's what I'm getting from this.
Where is S? What does that mean?
And SAT, I assume.
Hey. Aw. Just ask Jana.
Jane. Jana.
It's Jana.
Right.
Thank you.
Maybe it's pronounced Jane, though.
We're trying to spread this channel.
Yeah.
We want people to watch it. We're trying to give back
Yeah.
to the people. You know?
Yeah. And any money you give us, we'll give it straight to the SAT.
Oh, thank you for following. What did the Roman emperors say? Bread and circuses. It's like, how do you pacify your population?
Yeah.
Give bread and
Let them
circuses?
eat bread in circuses.
Yeah. So anyway.
Did you like that? Or did that make you very angry at me?
No, I try not to smile. I don't want to give you the satisfaction. Too much talking, too little math. Roby, we can say the same thing about you. You have done no math on this so far.
Yeah.
You just keep chatting us, and you don't do any math. No. What? That's what he/she sounds like.
Sound like an expert to me. Here's the thing. We don't produce the questions.
Yeah.
You produce the questions.
This is the end of the channel, by the way. I mean, today.
No, this is the end of the channel.
We did a crap ton of math, yeah. You just said the password that ends the whole channel. Too much talking, too little math. We are shutting down as of today. That's what we were looking for the entire time.
Yes.
Yes.
It's been good.
We want to do it?
No.
Well, no, we'll prove to her that...
How dare you? No. What's going on? No, we're not done. We do this Tuesday, Wednesday, Thursday.
6 to
Believe the
7:30.
sign. Due west. Also, I'm a CS major. I read that as I'm a cis major.
Oh,
Which
that's
is-
good. That's
I
great.
actually do think that's
Are we
pretty
sure it's not Rob Yex Pert?
I think it is. Pert's it's like a nice shampoo.
Or it's the formula for continuous compounding. Or maybe it's Ruby Expert because you're a CS major and we just saw right through you. You like Ruby. Ooh, you have a crush on Ruby. Because it's fun to waste our time. Because we're wasting yours. It's just it's a mutual, consensual wasting of each other's time.
Yeah. The important thing is time is stupid.
Yeah, it really is. They've done
Yeah.
tests.
Yeah.
Time is like a IQ of like, oh jeez, man. It's like oh god, like it's 70.
70.
It's like 2 standard deviations below the mean.
Yeah.
Yeah.
All right. This has regressed a decent amount.
A little bit.
So, if you're watching, we normally don't have people ask questions in. Yeah, don't believe in time. That makes sense.
Do you believe in lowercase time? Because that's
Yeah.
uppercase time, which is a little different.
Very good. Oh, there's something cool. So, don't respond the way I know you're going to because I hate it so much.
I like cool things.
So, if you're thinking about a two-dimensional plane, say we were to live in 2 dimensions. If a
Flat
3-dimensional object
Yeah.
passes through,
Cross section.
yeah, then it's a cross section.
Yeah. Okay.
I
Keep
thought
going?
this is interesting.
Okay. Keep
And
going.
so then, like,
4-dimensional time.
Yeah.
We 3-dimensional
how would
snapshots.
that go through?
Yeah. Right.
Yeah.
We live in that.
Yeah, I made up that idea.
No, you did not.
I was just reminded of it today. Time is wibbly wobbly stuff.
No, I mean,
Yes, that's very true.
I want to just annoy you by beating you to the punch, but it is a fascinating idea.
Yeah.
Which also,
So you're impressed that I came up with it?
right? Yeah. You can say that, I guess.
So aggressive.
Sure, you did. I think it's interesting because I feel like all snapshots of time do exist. Like there's that worm of the.
Yeah, that's right. I don't know what this emoji is of this black and white person, but I feel like it's Eleanor Roosevelt.
No, I feel like it's Steve Bannon. I've always felt like it's Steve
I've
Bannon.
always felt like it's Eleanor Roosevelt. And we always mistake those two for each other.
Steve Bannon, Eleanor Roosevelt, the same person? Not at all! The third guy's missing, or you fired him. We know where he is, and we didn't fire him. So both of those things are wrong.
He could be missing. I don't know exactly where he is right now.
True.
Yeah.
Yeah, we don't.
He's very easy to find.
Yes, he is. It's like,
He can't really hide in
where's
small
Waldo?
places.
It would take him a second. Just, oh, there he is. It's right there.
Yeah.
We gotta go.
Yeah, we have to go. But normally people ask us questions in our Discord, not in the chat here. Stop it.
Well, this is my punch down.
Yeah, I know.
It is how to say you are being sarcastic. It is how to say that you are being sarcastic.
Oh. Really? Oh.
Oh, that little face?
I'm going to explain that to Brady because Brady doesn't understand anything.
Yeah, no, it's all... Whew.
You're my dumbest business partner.
That's the only thing I
Did I tell you
know,
that?
is that all things just go right over my head.
Make that noise too.
Whew.
All right. Have a good night, everybody.
Should we do a different... We're nerdish robots in disguise.
We should do it again because...
jeez.
Sorry, I didn't know what the mouse said.
How about McDonald's?
Old Nick Nerdish had a fight.